Okay. So in today's class, we will start this new paper, which is the computational physics, okay, and Python programming. So, so first of all, we will consider the basics of this programming. Why we need this programming, and where we will use these programs, or how we will use these programs in different applications. Okay. So here, first we will consider the languages, different languages, for example, C, other C++, Java, or any such languages. So why we need these languages basically? So language, by means of language, we can communicate very easily, or it is a most effective tool for the communication. Okay, if you know the language, you can communicate much easier. If you do not know this language, any language which is in between two common people, two persons, then the communication will not be that much effective. Okay, so in order to have a smooth communication between two individuals, the most effective tool is the language. Okay. And now the question is, if you are communicating with another person, you can use normal language. We usually doing in our day-to-day life. But when you are communicating with a system, a computer, how we can do that? If you are considering, if you want to communicate a system or a computer, how we can do such kind of a communication, and there also we need this kind of languages, or we need some kind of instructions, or we can also call them as the programs. Okay, so we have to design some sort of instructions or programs that we will give to the system, to the computer, and the computer will work according to these instructions. Okay, so that's how we communicate with the computer system, or the any such kind of device. So we basically make a set of instructions, which is called as program, and then that program will be running in the system, and the computer will understand the commands, or the instruction that is inside the program, and it will do the works, or any kind of activities according to that particular instructions. Okay, so here, so for that we need language that both computer and human can understand. In the first case, if you're considering two persons communicating each other, and the language that they will use will be understood, should be understood by both of those individuals. Okay, otherwise the communication will not be that much easy. So in the same way, if you are communicating with the system, the computer, we need to have a language which can be understood by the system, by the computer, as well as the instructor or the programmer or us. Okay, so that is a necessary condition. If the system do not understand the language that we are using, or we are providing to the system in order to complete some tasks, then the system, we need additional programs or instructions to change that particular program into another program which can be, or instruction which can be understood by the system. So we need additional requirement in such kind of situations. Okay, so basically in order to communicate with the system, we need a language. Okay, that has to be understood by the instructor, or the programmer, as well as the computer system. So here we will consider such languages that we will use in order to communicate the system, or the computer system. So here we will classify the basic languages that we use this kind of a communication, that will be classified into two, which are high level and lower level languages. Okay. So, so basically, this language, computer language, if you consider, these languages can be classified, into. So I'm talking about the uh, computer language or program language. Okay, so that can be classified into two. So I'm talking about these program languages. Okay, program languages that can be classified into two. One is low level language, and the other one is high level language. So these program languages can be classified into low level language and high level language. So here the language that deals with the computer hardware, okay, that kind of languages. So basically, we will not understand such kind of language. For example, if you consider any binary codes, okay, if you directly give binary codes to the system can easily understand binary codes because it is the machine language. So that is the machine language, that is binary code. But understanding binary code is very difficult for human beings. Okay, but machine can understand these kind of binary codes much easier than any other languages. So that is the system language, or we can say that computer language. So we use binary codes like, for example, if you consider something like hi, when you're writing something like hi, okay, this we can understand. These things, hi or hello or any such kind of words, mnemonics that you're using in our day-to-day life, that we can understand very easily. But if you're converting that particular instruction into some binary code, for example, let's consider this hi is something like 0 1 1 0 1 1 1 0, some kind of binary code, then that is not able, we cannot understand this kind of binary code. Okay, but the system, the computer will understand only this kind of binary codes. Okay, the computer will not understand this kind of text or something or mnemonics that we use. Okay, so we cannot understand binary code, but the system or the computer can understand this. We can understand this kind of code by using normal texts. We can the words that we use normally in our day-to-day life, that we can understand, but that words will not be understood by the system. Okay, so that is the difference. So if you are considering the human beings, if we consider human beings, then we'll be having this is the condition for humans, and this is the condition for a computer. So a computer can easily understand these binary codes, okay, but it will not understand this kind of texts, normal texts or something like that. That it cannot understand. But for humans, this kind of text or the words, all those things that we use normally in our day-to-day life can be easily understood. But these binary codes, that is not possible. Okay, that we cannot understand. So I think I miss. I should write it like So, oh, so okay, so humans can understand this. So this is corresponding to humans, and this will be corresponding to the computer system. Okay, so the computer can understand this one, it will not understand this one, and the humans can understand this. So what actually we need? We need some program that both or language that both the system as well as the human beings can understand. Okay. So, as we said, this is the language that the system can easily understand. Okay, any language if you use that has to be converted into binary form 0 1 1 0 0 codes. Okay, such kind of a code. If you want to give that instruction to the system, and if the system has to do some work on basis of that particular instruction, that has to be converted into binary code, because the system only understand these binary codes. So if you are converting this high into this particular code, then the system can understand that particular message. Okay, otherwise the system will not understand that. Similarly, if you change this binary code to this form, if you're having any program to change this binary code to this form, and then the humans can also understand that particular statement. So in between, we need something to convert our normal text that we use in our day-to-day life into something that machine can understand. And similarly, the language that is understood by the machine, that is the binary language or binary values, that has to be converted back to the textual form for better understanding for the humans. Okay, so if you consider this low level language, these languages that deal with the computer hardwares. Okay, this basically deals with this low level languages deals with computer hardwares, computer hardware. Also, the constraints it has. So this is basically deals with the computer hardwares, and because of this there is very less freedom. This is very less freedom. We have very less freedom in here. If you consider computer, so the instructor cannot have much freedom in if you are using this kind of languages, because this is highly dependent on computer hardware. Okay, because for example, if you consider a CPU, how the CPU works, we will discuss that microprocessor section. I will send that recorded class, so that you can understand that better. But I will just give you a simple uh, diagram here. So if you consider the CPU of any computer system, okay, that is the core of this computer system, or that is the central processing unit. Okay, so if you do any work that has to be done by this computer, and that instruction has to be passed by the CPU into the corresponding system. For example, if you want to take if you want to take a printout from your system, then the CPU has to send a message to the external printer, or the data has to be sent, the signal has to send to the corresponding application in such a way that this data can be sent to this external device or printer. Okay, if you want to take a printout. Okay, and if you do any such kind of operation, first the instruction will reach into the CPU. Okay, and the central processing system unit will understand what instruction it is, and then that will give commands or the signals to corresponding devices or corresponding locations accordingly. Okay, so the CPU will consist of all these kind of uh, internal architecture that we'll discuss when we discuss the microprocessor. We will discuss all those things. So basically, we will be dealing with this CPU inside the computer and all the components inside this computer. For example, if you consider printer, if you consider mouse, keyboard, all those things. If you consider the display unit, which is it may be LCD screen or something like that. So all those things will be working on the principle of the binary codes. So the language that is uh, the system used to communicate with these devices, external devices or internal devices, will be the binary code. Okay, so this, for example, if you want to take a printout of hi, so hi is converted into this binary form, and that code will be sent to this printer. Okay, so for example, 011 01110, that will be going through this printer, and by using some application that has to be converted, and all those things will be there. For example, if you are writing in the word, then correspondingly we have some alignment and all those things will be there. So all those things has to be taken care. But simply, if you consider this high only, we have to take out from the print, and at least unit this code has to be passed through to this printer. Okay, or some other code which is converted by some other application which we use to write this particular text high. Okay, so basically the system will communicate its internal hardwares by using this binary code. Okay, all those devices inside your computer system will be communicating by using this binary code. But we humans cannot understand this binary code, or it is very difficult. As you can see, this high is written here. If you are considering some paragraph, then it will be a large number of binary code or binary numbers. Okay, then that is very difficult to understand for the humans, but the system can understand that very easily. So these low-level languages basically deal with such kind of computer hardwares, how the CPU can work, how the CPUs can send information to other devices. Okay, all this will be done by this or controlled by using this low-level language. Those programs that has to be done by the CPU, by any other computer devices, computer parts. Okay, that particular program will be designed on basis of these low level languages. Okay, so low level language means it deals with computer hardwares, and we have very less freedom on those languages, because it is completely having these binary codes or some particular very hard codes that the humans not having that much access. Okay, so that there we use this low-level languages. Basically, these low-level languages are used by the system hardware to communicate within this system, and usually that will be some very complicated code. Okay, so this also we can say this is the computer native language. This is computers native language. We all have this native language that only some particular people can understand. Similarly, computers native language, we can say that is this low-level language that these languages are used by this computer system to communicate within the system, within these hardware parts, different devices inside the system, different parts inside the system. And this low-level language we can convert further. This law language can be classified into two again. One is called as machine language. One is machine language, and the second one is called as assembly language. Machine language and assembly language. For if you consider the machine language, this is nothing but the computer language, purely that binary codes that we are using. This is nothing but computer language. This is computer language. Okay, and simply this is using binary codes, using binary codes. So writing something in machine language is very difficult. You have to write binary codes if you want to write any program by using machine language. And by using this machine language only, that CPU and all the other devices inside your system will communicate each other. Okay. So, for example, if you can consider any text, as we said earlier, hi, that has to be converted into binary, and that binary number, okay, that will be used by your CPU or any other computer system. Okay, this is how the computer communicates, or the digital device communicate to its different components. If you consider, if you are clicking on your mouse, or if you are using some keyboard to enter a particular number. Okay, so if you are having a display like this here, and if you are connected this into the CPU and all those things, and if you are pressing something, for example, letter A here on your keyboard, then that A has to come on the screen. If you are writing something on the Word document or something, then that A has to come into your screen. Okay, how it is coming? The keyboard has to send some kind of signal to the CPU, and CPU will understand that you are now typing something in Word document. Okay, so that the A letter has to come on your display, and the CPU will send the information of signal to the display unit to show this particular A letter A in this screen. Okay, that is how it will work. So when you are pressing this A, these all this process will happen within a fraction of second, and the A will be displayed, letter A will be displayed on the screen. Okay, so when you are pressing, actually when you are pressing this A, your keyboard will be sending some kind of binary information through these cables to the CPU, and from the CPU, it will send corresponding signals to the display unit, your display monitor. Okay, and that will give some kind of, for example, LED glowing on something, and that will be displayed on your screen. This is same for your mobile phone also, same in all the digital devices. The process is same. So basically they are communicating by using this code, by using binary codes, and these binary codes are nothing but the zeros and one, and with that zeros and one you can make programs, you can create programs, and you can directly control these devices, these mouse, keyboards and monitor. You can control, for example, if you say, if you are using something like this, 0010, and that is representing keyboard, for example, I'm saying for example, so this is representing keyboard, so the CPU will understand. For example, if you are using some 32-bit system, then it will be having 32 binary bits, and if you consider some smaller value, for let's say some 20, each one will be having some four binary bits. So let's consider some information like this. Okay, so this is associated with some kind of instruction sent by some device to the CPU. So for example, I can say this 0010 is corresponding to keyboard, coming from, because the CPU has to understand this signal is coming from keyboard. Okay, so that this communication between these devices inside your computer system is controlled by these binary codes, and this can be created, or this can be made by using these binary codes. This can be controlled by using this binary code, so we can create some program in order to have some particular kind of function, or some particular kind of operation that has to be performed by these devices. Okay, so all these devices will be communicating these binary codes, communicating by using these binary codes, and if you can manipulate these binary codes, then you can change the action of these devices. For example, if you consider the printout, for printout we are having for example, control P, shortcut for this printout is control P, control and P you have to hold, and then the signal will be sent to the printer, and we will get a printout. Okay, that is the shortcut of that. How we will design this shortcut? And we will design the shortcut by using these kind of programs. Then we will design, if you are pressing these two buttons, there will be some corresponding binary codes for these two buttons, and that will be sent to the CPU, and the CPU will understand you are pressing this control and P. Okay, so correspondingly there will be some binary format, and that from that binary format CPU will understand. How CPU will understand? We will be programming CPU in such a way that when this kind of binary code is coming, you have to do this kind of signal has to be sent to this particular location. Okay, so this signal will be sent to the printer. This is how this system will operate for executing different operations. So here, this CPU is programmed this keyboard according to these keyboards and other devices instructions, so that the CPU will do the works accordingly. So, in order to have these kind of operations, by using this computer system, we use machine language, and this is also called as the computer language. So, this machine, if you are doing any programs by using machine language, that means you have to do that by using the binary codes itself. You have to use only the zeros and one. Okay, so that is also the drawbacks of this machine language. It is very hard to write. It is very hard to write or create a program by using this machine language. Okay, also it is very difficult to understand. It's very difficult to understand. Okay, if you're writing something like 0 0 0 0 1 0 1 0 in an entire page, that is not going to be understood. We'll not be able to understand that particular code very easily. Okay, so it is very difficult to understand, and depending on the computer architecture, this program will be different. So if you are using some program designed for mobile phone, that cannot be used in a computer system. Okay, some if you have designed some particular program for some particular architecture, some particular CPU configuration, that will not be that cannot be used in some other systems. Okay, that program will not be because it depends on computer system. If you are using 32-bit system, for example, if you are considering a 32-bit system, then that particular program will be running in 32-bit system only. We cannot use such kind of a program in a 62-bit system. Okay, so it depends on, since it is depending on the computer architecture, we cannot port. Okay, the program we cannot be ported to uh, any other system. So this is depending on computer architecture. So which means that not portable, not portable. So what that means, which means if you are making some programs for some particular device, some particular hardware, or some particular system which is running, for example, 32-bit, that cannot be used in some other system which is having some different computer architecture or some different configurations. Okay, so it is not portable. Basically, it is not portable. So if you want to make any language any program on the basis of machine language, first you need to understand what is the system architecture. The system architecture has to be understood clearly. Then only you can make the program by using this machine language. Okay, so if you're using some 32-bit system, which means that they will be having 32 channels in that. So if you are using 32-bit, then you have to make that particular program accordingly. And if you are having 64-bit system, 64-bit system, if you are considering, then you have to change the program accordingly, because in 32-bit system you will be having 32 binary codes. You can use 32 binary code maximum, but here, if you are using 64, then you can have go up to 64. So a 32-bit system, if you are having a program which is on the basis of a 32-bit system, that will not be. And if you are using some other in for example, maybe in 64 it can support. If you are using any 64-bit system, a program which is meant for 64-bit system, that will not be supported in a 32-bit system. Okay, so it also depends on your computer hardware, how it is, its architecture, all those things will be depending, that depends on this kind of programs. So depending on your computer architecture, these programs has to be modified. Otherwise, that will not be executed in that particular computer system. Okay. And one advantage of this machine language is that this is very fast, because the computer can directly execute the operation here. Computer can directly execute the instructions for operations. So what that means, because of this, it is going to be very fast. Because when you're writing something in binary codes, the computer can easily understand that, and the computer will do the task very easily. So we do not have to convert that particular program into some other language. That is not needed here, because we are already making that in the binary form. Okay, so that the computer can quickly or easily understand this binary data and execute the program much faster than any other language. Okay, so that is the advantage of that. Now if you consider the assembly language is also a low level language. Low level means the we are using it in a system configuration, or we can say only that system can understand that data much easier as compared to we human beings. So this assembly language, there is slight difference. Okay, so this can be understood by the programmer. Understood. This can be understood by the programmer. Okay. Uh, and also computer cannot understand it directly. Okay, computer cannot understand understand it directly. Okay, so here we use some additional language, or additional software, sorry, program to convert this particular assembly language into machine language. Computer will understand only this machine language, and when you're using assembly language, the instructor or the programmer can understand that particular language a little bit. Okay, and the computer cannot understand that particular language directly. Okay, then we need some kind of conversion from that assembly language into the machine language, that will be performed by using this assembly. Okay, so here we need assembler. It's spelling. Okay, Okay, here we need assembler to convert that particular assembly language into machine language. We need assembler to convert assembly language into machine language. So here we have D, I think. And here also, this is also depending on, this also depends on computer architecture. Computer architecture. So this also depends on computer architecture. Depending on your system configuration, the program will be different. So one program designed for one particular kind of system cannot be used in another particular in another system which is having some different architecture. Okay, architecture means how those CPU, the microprocessor inside your system that is communicating with its components, the ALU, arithmetic and logic unit, controls signals, signal unit, memory, and all those things. Okay, together, that is your the architecture of your computer. And if your that particular architecture is going to change, then we need some other program. So in each of this computer architecture, we need different programs. Okay, so this assembly language also depending on the computer architecture. So when we need to understand the computer architecture thoroughly in order to uh, design program on basis of assembly language also. Okay, so here we normally use some instruction when we do with the microprocessors. For example, 8085 microprocessor and all those things. We will do some command like add. Okay, for example, if you want to add two numbers, then we'll use command like add, or if you want to subtract, we'll use some instruction or command like sub sub. Okay, so this kind of small instruction is possible in assembly language. Okay, here only 0110 is possible for machine language. Here we can have some kind of this kind of um, instructions, but this is highly dependent on the system architecture. If you are using that this particular command in one system, and that may not be same as of some other system which is having some different architecture, some different configuration, that will be different. Okay, so here only this particular commands will be applied, or this if you are using this particular instruction or program by using this assembly language, that will be useful for that particular system, that with any or any other system with that particular architecture. It will not be able to run in any other kind of system with a different architecture. But here we can use some kind of instruction like this, that a programmer can understand what is this add sub. So some kind of connection to the real world can come in this assembly language if you are using assembly language. So this add has to have convert into this binary code, this sub has to convert into this binary code. So for example, this add will be having something like 1011. I'm just giving some example. So this abstraction will be something like this. So this has to be converted into this form initially. That is this instructions has to be converted into this machine language or binary codes. For that we use this assembler. For that we use this assembler. So assembler is required when you are writing any program in assembly language. Okay, that has to be converted into machine language. Then only the machine can understand that particular instruction. So here also we can see it is highly dependent on computer architecture, and it is not portable yet. So in order to avoid these limitations, and to understand the program more easily by the programmer side, okay, rather than the computer side, we have developed some other languages also, which are called as high level language. So we'll look into this. So we'll talk about this high level language now. So now we'll discuss about these high level languages. That is second type. So in this high level language, the Python also comes under this category, high level language, and you can consider the Java program and other programs in here. So so this Python we will be discussing in this complete course, this paper. Okay, so that is nothing but a high level language. Okay, so when you are considering this high level language, these languages are very close to human beings. It is very close to the programmer or human beings, or we can say these programs can be understood by the programmer very easily. Okay, and this is independent of machine. This is independent of of machine. Okay, since it is independent of machine, it needs to convert into machine language. So it has to convert into machine language because it is independent of this machine. Okay. Yeah, that is. So in order to do this conversion from this high level language, any high level language to machine language, we need some kind of converter. Okay. And these converters are the compiler and interpreter. This conversion can be done by using compiler and interpreter. So now we are considering high level language. This language can be understood by the programmer or by human beings very easily. Okay, and it is independent of machine. And if because it is independent of machine, we need to convert that particular language into machine language before executing it. If you want to do any program, any kind of action based on that program, so that has to be converted into machine language. And in order to do this conversion from the high level language to machine language, we need compiler or interpreter. So So since this conversion is required, it takes more time. Since this conversion is required, because we are actually writing program in some language, in high level language, and that has to be converted into machine language. So it requires some time. So this one will take more time. This one will take more time. More time required to execute. You can refine this things. So basically, it require more time to execute any program or instructions. Okay. So these are the important points in this high level language, and this high level language includes the Python, Java, all other programs that can be understood by the programmer. Okay. So here we can write directly. For example, if you consider summation, you can write directly S equal to A plus B. Okay, this kind of statement can be written in this kind of language, high level language. When you are writing the program, you can write directly sum or S equal to A plus B. So this can be understood by the programmer by very easily as compared to the previous languages that we explained. So here we are, if we are using these high level languages, that will be understood by, or that can be understood by the program very easily, but it will not be understood by the machine. So we have to convert that particular program into machine language to the binary codes, like 110 equal to something like that. And if you want to convert that particular code into the machine language, then we need this compiler or interpreter. When you are converting that high level language into machine language. So here actually we need okay. So here we need, for example, if you are using a 32-bit system here, if you are using 32-bit system here, let's consider, or let's consider 20-bit system, for example. Okay, so 20-bit means we will be having 20 bits here. For example, first 101, which is used for the addition, okay, code for this one. That is opcode. This is called as opcode, operational code. That is used by this plus symbol, and the remaining numbers are used or digits are used. For example, 8 digits. Next 8 digits are representing the number A, and the remaining numbers 8 digits are used for representing. This one is 6 only, so let's consider. Let's just simply okay. So when you are considering the next 8 bits for A, next one is this 8 bits for B. So this is this instruction that is S equal to A plus B. This A plus B has to be converted into this kind of binary code. So this one we are writing this code in the machine language. Sorry, in the high level language that has to be converted into this machine language into the binary form. And here we use compiler or interpreter. Okay, so how this compiler or the interpreters are different, how they are different, that we will discuss now. So in order to discuss that, first we will consider these are nothing but language translators. Okay, language, you can say they as language, you can call them as language translators. Language translators, and here we are having assembler as well as interpreter. Okay, so when you're considering this assembler, when you consider the assembler, what assembler will do? So assembler, when you're writing some high level language or assembly language, for example, also in the case of assembly language also we use this. So when you are writing any sorry, assembler will be using when you are considering the assembly language. Okay, so we are categorizing them in a broad classification of language translators. So first we will discuss about this assembler, and then we will go to the compiler and interpreter. I think we have done the same, right? Here we okay, compiler and interpreter. Okay. So first we will discuss the assembler. So where assembler is functioning, or when we need this assembler, if you want to convert any code or instruction which is written in this assembly language into another or the machine language, then we need this assembler. So the assembler is required when you are converting. Assembler is required when you are converting assembly language or program from assembly language. I think that is completely T I had to write. I'll just erase that. And this is taking some time. No, it is not responding to this. It is not coming. I don't know this. It's coming. Okay, so what happens? So we were discussing about the different language translators that we use in programming. So, yes. So we were discussing about this assembler. Okay, assembler where we'll use this. This assembler can be used in. This has to be B. Assembler. So this assembler will be using when you are having something which when program which is written by using the assembly language. Okay, so the program with assembly language. Program with assembly language. I will just write okay, assembly language that has to convert into the machine language. Okay, so that in that situation we need this assembler. In that situation we need assembler. Okay. And we have the other two, which is nothing but which are the compiler and interpreter. Compiler and interpreter. And compiler and as interpreter, as you know, that we will use this compiler and interpreter. These are computer programs. Okay, all these are computer programs used to translate. Used to they translate.
Sir, screen കാണുന്നില്ല. Screen കാണാൻ പറ്റുന്നില്ലല്ലോ.
Okay, okay. ഇപ്പൊ കാണില്ലേ?
കാണുന്നുണ്ട്.
Okay. So this assembler we will use to convert from the program which is written in the assembly language to machine language. There we will use assembler, and this compiler and interpreter we will use when we want to convert a program which is written in any high level language by Python, Java, C, or any such kind of high level language that has to be converted into machine language. Then in such situation we use compiler or interpreter. Okay. Okay. So now we'll discuss about this compiler or interpreter. So let me just erase this. Just taking more time. Okay. So let us consider the compiler or interpreter. So these two we will use when you are having program written by program with high level languages into machine language. Okay. Now why need compiler and interpreter? In the previous case we are having only assembler. Here we are having compiler and interpreter. What are the difference between these two translators? If you consider the translators of this high level to the machine language or low level language, especially to the machine language. So in that case, we are using interpreter as well as compiler. What are the difference between these two, interpreter or the compiler and interpreter? So that we'll discuss now. So compiler, in case of compiler, it converts the entire program before execution. First point is that it converts entire program before execution. So what that means, if you are having any program in your system which is written by using any high level language, that has to be converted into machine language. And if you are using compiler, then this compiler will convert that high level language into machine language entirely before execution or before executing the program. So first it will convert from high level language to machine language. Okay, but in case of interpreter, we are having here it converts program while the program while execution of program, you can say. Of the program, execution of it, which means that it will convert the program at the same time it will execute the program. Okay, so here this is nothing but a line by line execution. Line by line execution. Okay, so what is here? We, for example, if you are having some kind of program which is written in the high level language, that has to be converted into machine language. So in this particular case, if you are using the compiler, and the entire program will be converted into this machine language form. Like here, first it will convert into a code. First it will convert into object code. So here we will be having something like object code, object. So we'll be having object. So first it will convert all this program into object code, which means that it will be converted into that binary form that can be understood by the system. And after that only the program will execute and we will get the output. Okay. So first it will convert all the program into the object code, and then object code is nothing but that binary format into the machine language, in the machine language. So this program, which is in the high level language, this program is in the high level language and written in the high level language, that will be converted by using this compiler. And here we are having this compiler, and that will be converted into object code, which means that it will be converted to machine language and then we'll get output. But here, for the case of interpreter, I erased something. No, it is not coming. So it will be converting program while execution of the program. Execution of program. So which means that it is a line by line action. Line by line execution. This is a line by line. This is a line by line execution. Okay, so which means that if you are having any uh, program which is in the high level language, okay, so first it will convert the first line. Okay, it will take this first line, will take this first line and convert into the object code that the system can understand, and also execute the program, execute that particular line, and then that will give you the output. Okay, so this you will get output here. So here we are having that interpreter. So when you are using interpreter, it will take this particular line, first instruction, that will be converted into opcode, and also it will be executed and you will get output immediately. And after this first line execution, it will take the next line. Okay, so this interpreter will not take whole the program and will not convert into the object code or the machine language initially, but it will take line by line execution will be happening. So first it will take first line, and that will be converted and executed, then the next line and converted and then executed, and immediately for all those instructions we will get the output. Okay, so there is no object code formation here. Here only we are converting directly from the high level language, and using this interpreter we are just converting and taking the output after execution of each line. So it is a line by line execution. But here we will be converting the high level language into an object code, which is in the machine language form. And then that after making this object code, again this program will be executed and we will get the output. So in that program will be executed and we'll get output. But here line by line execution will be happening. So when you're considering the speed of the operations, if you're considering this the speed here, this will be faster. This will be faster. Why this is faster? Because it is converting the entire program at a time into object code and taking the output or executing. But here it has to complete each of this conversion and taking output by line. Okay, so here we have to execute line by line, so that it will take more time. So here this is slower. This is slower as compared to compiler. This is lower as compared to compiler. Here it is faster in this case of compiler. Okay, another important point is that here debugging is difficult. Here debugging is difficult, but here debugging is easy. Why it is easy here? Because we are doing line by line execution. So in any case, for example, in the third line we are having some error, instruction error, then that error can be easily identified when you are reaching this third line. First line executed, second line executed. When it is reaching at the third line, then the program will the interpreter will understand there is some error in this program. Then the interpreter will immediately terminate the execution of that particular program. Okay, so that we can easily understand the error where they are. Also we are having this line by line execution when you are using interpreter, so that we can understand where which in which line the error is. Okay, so the by using interpreter we can also get information about the error location, in which line the error it is. But in this case of compiler, if you are using, debugging is difficult because first it is converting the entire program into the object code, and then execution happens. So we cannot understand in which line of our high level language actually the program error is. And even though if you are considering this case, this entire code is first converted into this object code. After that only we are getting the debug or error in the program. So it is difficult to locate, or it is difficult to debug or remove the program error when you are using this compiler as compared to the interpreter. Here we can easily understand the error and easily locate the error in which line it is, but here it is difficult. Okay. And also here, an advantage is that once one compilation is over, so once compilation is over, the source code is no longer required. What that means, if you already converted this entire high level language program into the object code, okay, and this particular instruction or language program is called as your source code. This is your source code. Okay, and once you convert this entire source code into object code, then you do not require this source code anymore. This source code is not required because you already have an object code of the same in your system. So this source code is not required once you execute, or once you have compiled all this high level language program into the object code. Okay, but here we are not converting this entire source code. This is our source code. So this source code is not converted into an object code. So hence, in the case of an interpreter, we require this source code when we are running the same program repeatedly. Okay, so here we require this source code again and again, because when you are running the program again and again, this source code is must. But in the when you are considering the case of compiler, once you compiled into compilation is over, this source code is converted into this object code. Once that object code is created, then only we require only that object code. We do not require this source code anymore. So we can change the location of this source code into some other location. We do not require that particular code in our memory. Okay, so memory also, in terms of memory, we can have some more memory, because source code is not required for execution when you're using compiler. So once compilation is over, the object code is enough to do any repeated action of the same program. But here we need the same source code when you are using that program, or if you are having same task again and again, we need same source code, and we have to go line by line and again. Okay, and So here we need also we can consider this part. Okay, in case of memory, one more thing is that converting that into object code. Here it is converting. What is this source code. Even though we do not require this source code, but since we are converting this source code into object code, so here this require need with this need more memory. This need more memory because we have this object code in your memory also. At the time of this conversion, we have both this source code as well as object code in your. But here direct output is taken. Okay, directly this one directly gives the output. The interpreter will directly give the output. So no object code is formed. So here directly gives the output and no object code, which implies less memory because we do not require any memory for this object coding when you are using the interpreter. Okay, so in a simple way, I will write it here itself. So we can say here it is source code can be converted into compiler. The compiler will use this source code, okay, and then it will be converted into the or I will do it in a different way. So I can write it like this. We are having source code, and that has to be converted into object code. So here we need that compiler, and this object code, from this object code we will get the output. But in the case of interpreter, we will be having source code here. Source code. We use interpreter, and here we will be getting output. So this is faster. Interpreter will be faster as compared to the interpreter. It will take more line by line execution, so it will be slow. But here we will get direct output. We do not have to convert that particular operation or the source code into an object code. That process is not required in the case of interpreter. Okay, and I also have prepared for this Python introduction, but I was not having the I think pad. So I'm using some other system. So we'll take that part in the next class. Introduction to Python and Python programming. We'll start in the next class. Okay, so if you are having any doubt, you can ask me.